Hello, good evening, all. We will begin in 5 minutes. 5 minutes. Let's wait for others also to join. Okay. And today we will be solving the numericals on latent Dirichlet allocation and topic modeling, and one or two questions from WordNet similarity concepts. Okay. So please be there. We will begin shortly. Let's wait for 2 to 3 more minutes for others to join. So we'll begin shortly. Meanwhile, I'll share my screen. So do you have any specific doubts from week 9 assignment? Have you all watched the video lectures and attempted to solve the assignment? Yeah, so just a second. Just give me a minute. I don't know like what is the issue with this. Yeah, okay. Just a minute. Yeah, so I hope my screen is getting shared. Can you see my screen? Can anybody please confirm? Are you able to see my screen? Okay, great. Audible as well. Thank you for confirming. So, I think let us begin. Let us begin. So, could you all please try this question? So, we know what is the basic equation, probability based equation for topic modeling in latent Dirichlet algorithm. So, we have two parameters, alpha and beta. So it is asked in topic modeling which hyperparameter tuning used represents the topic document to topic density. So I would encourage all of you to solve it and put your answers in the chat box. We will discuss each question one by one. So if you know the equation, just please write it, and from there you'll be able to figure out what is for the topic document density and what is for the other distribution. So I hope this topic is clear to all of you. Latent Dirichlet allocation. Just a second. I don't know what is happening. Yeah. So this is the first question. All of you should attempt. I'll also solve it. But if you have solved, then please write your answers in the chat box. So is this topic clear, or do you want me to explain topic modeling first, this latent Dirichlet allocation? First, please let me know this point. Do you want me to explain it first? Okay. So how many of you want me to explain LDA first? Like the basic concept of it? Okay. Anybody else? Okay, okay. I can see two hands. Okay, then first of all, let us discuss what topic modeling is. Like I'll give you an idea. So then after that you may attempt to solve. Just a second. Yeah, so yeah, by the way, answer B is correct. Just a minute, let me get my pen. Just a second. Okay, so let us discuss. So, I'll ask, and if you do know, please unmute and please discuss. Okay, so let us study this. So, first of all, tell me, do you know what is the meaning of this latent Dirichlet? I hope that is the correct pronunciation. Allocation. So what do you mean by latent here? Let us first understand the terms and then we proceed towards discussing the concept. What do you understand by latent in general? So latent here means that it is hidden or it is not known to you beforehand, not known a priori. A priori means it is not known to you beforehand. What is not known? So it is not known, and also you know that latent Dirichlet allocation is it a supervised or an unsupervised algorithm? First of all, tell me this. How many of you believe that it is a supervised algorithm? Kindly raise your hands. I want you to interact as much as possible. Yeah, that's correct. It's an unsupervised algorithm. So it's an unsupervised algorithm. Now, first of all, now that this point is clear, I'll be covering why is it unsupervised. Let me discuss this. What is latent? What is not known here? So, what is not known here is the topics. The different documents that you have, to which topics they belong, that is unknown. So, topics are unknown. That is, they are hidden in the data. So these topics are hidden in the data. That is what latent in the LDA means. So the, the topics, the document belongs to certain topics. Okay, the document always belongs to certain topics. Topics are believed to be there. Topics are believed to be present. But what those topics are, that you don't know. Therefore, the text is generated. So you see a lot of data is there in the form of text. Either it is the social media posts, news articles, Wikipedia articles, tweets. All of them are primarily in the form of text. And all of them, if you see, they talk about a specific topic, be it sports, politics, army, entertainment category, education, industrial, corporate jobs, or anything. So it is always believed that the topics are there, but what the topics are to which a particular document belongs, that is not known. So and always a text is generated based on these certain topics, right? So the what is hidden in LDA, if somebody asks you, so you should be prompt and tell the topics are unknown, they are not known to us beforehand. Okay, and Yes, you don't know. That's correct. So I'll give a brief introduction and then we go on solving the questions. Okay. And it is always assumed that your document. So Dirichlet means what? Dirichlet means it is a distribution of distributions. So you will ask me, what does this mean? Distribution of distributions. So that should be clear first of all. So it is always assumed that the document, it belongs to certain topics. Okay, the document is made up of, or the document is a distribution of the topics. And what are the topics? They are the distribution of words. So you can say the smallest constituent element is the words. There is a certain probability of the a topic will always see a certain kind of words, and if certain topics are appearing in a document, so that is this entire thing is known as the Dirichlet, that is distribution of distributions. A topic is believed to be a distribution of the topics, whereas the topic is believed to be a distribution of the words. Okay, so let me define it. So Dirichlet is distribution of topics in the document, and topic is and so topic is distribution of the topics in the document and distribution of words in a topic. Okay, now the third term comes. What is allocation? How do you allocate? So what is allocation? Once you have the Dirichlet, like what is the distribution of the topics in a document, what is the distribution of the words in a topic. So once we have Dirichlet, we will allocate topics to documents, because our job is to allocate the topics to the document. These topics to which a document belongs, that is not known. So your job is to allocate the topics to the document. And what are the topics made up of? Words. And words to words of the document to topics. Okay, so you can say that LDA, each word in each document comes from a topic, and the topic is selected from a per document distribution of topics. I'll give you one example also to help you understand what I am saying. Okay, so say here that I was talking about, now coming to that question that I was talking of, alpha and beta. So what was our question? So are these three terms clear? What is LDA? What does the term latent Dirichlet and allocation means? Is it clear? Yes, please. Deepa, do you have any query? Please let me know. Or do I need to explain in more detail?
Clear, ma'am. Clear, ma'am. Thank you.
Shall we proceed towards the question then? So see, what the question asked you was, in topic modeling, which hyperparameter tuning used represents the document topic density. So now coming how we will solve this, or what is the exact solution for this. So see here, so assume that in terms of alpha, TD, so that is the probability of the topic belonging, probability distribution of topics in a document. This is the probability distribution of topics in a document. And what is beta? So beta is the probability of the word belonging to a, so this is the probability
Is this alpha topic?
yes, please.
Is the other way? Beta was the question we saw. Beta was the hyperparameter of topic to document.
But according to me, I have written it like this.
Okay.
Yeah. So see, let me clarify this point also. Probability distribution of words in a topic. So ideally in the question they should be defining what alpha and what beta is. Maybe you took beta as this term and alpha as this term, and that's why your answer varied, right? Is that correct?
Yes, yes.
Yeah. Also, it may not primarily be alpha and beta. Maybe they take theta and phi. What should be clear to us is that theta, it represents the probability distribution of topics over the document, and phi represents the probability distribution of words in a topic. Ideally, you assume like this: the alphabetical order: alpha for the first thing, beta for the second, theta for the first, phi for the second. I mean, it's not an ideal scenario, but according to what I had framed in the question, it goes like this. Okay. So overall, what does LD come out as? So it comes out as summation of T belongs to T, probability of the word given the topic into the probability distribution of words given the topic in the probability distribution of topics in a document. So here, so LD equation comes out as sigma T belongs to T, probability distribution of words given the topic document into the probability distribution of topic given the document. So now you can ask why this term. Earlier I was writing it as probability of W given T. So let me tell you how I simplified this to this, or this to this. So ideally it should be, this should be simplified to probability of this into probability of T given T given D. So how? Let me tell you. And here, capital capital T is the number of topics, and so capital W or V, it is the number of words in the entire collection of documents. So what we also call this thing as vocabulary, right? We've seen this term beforehand.
It's the same as our corpus and dictionary, everything, right?
So you can assume it like the in case of word to vec, you create a vocabulary, or in the case of bag of words, you first create like what are your unique words that are appearing, right? So same here. What are the unique words over the entire collection of documents? Say I have given you 3 documents. So what are the unique words that are appearing? Like capital T is the number of the unique topics, and capital W or V would be the number of the words. Okay, unique words. So how did I get this term was, if I assume that we have conditional dependence, conditional independence. That's why how I simplified this to this. So also then what does this become? That the probability of the word belonging to a given document comes out as summation of T equals to 1 till capital T over. So this is the word to topic distribution into topic to document distribution. So you can imagine it like this as a combination of matrices. So this is the probability of the word belonging to a given document. Here it is having the dimension W cross D, where it approximates to W given T. So this is the word W that belongs to a topic T, that is alpha in our case, into beta times what it should be, capital T into D. So this is the topic belonging to a document D. Okay. So now tell me, do I need to further explain how we assign the topics randomly and then how we reduce and all of it? Or that point is clear? Okay. If needed, I'll take it up towards the end. So this question is clear to all of us now. So the answer is B. The Dirichlet hyperparameter alpha is used to control. So here Dirichlet hyperparameter alpha is used to control the document to the topic density or distribution probability. Okay, so that is done. Now the same question follows, word to topic density. So now what should be the answer? Quick.
Beta.
That is clear. So here what you could answer is C. So here you can assume that Dirichlet parameters, that is alpha and beta, or theta and phi, or alpha, gamma, delta, whatever the question says. So these are used to control what? These are used to control if all words have same probability in a topic, because this is the topic distribution of the words in a topic, right? Has same probability of belonging to a certain topic, or will that topic have extreme bias towards certain words. Okay, so this answer is also clear. So let me also explain to you. Just a quick question to all of you. Please raise your hands. So how many of you want me to like take up a short sample numerical, like a very short idea example to give you an idea of LD, or should I proceed with the questions that I have created for today? Yeah, so what do you want me to do? I'm not able to understand if you're raising hand. Do you want me to solve the questions or take a sample to explain one iteration of LDA? Please unmute and tell. I would proceed as you people want me to do. A short example. Okay. Okay, I'll try to keep the example short because I have both kind of the requests. I'll try to accommodate both. I'll keep that example quite short. So yeah, just a minute. So see here, if we take this example, it will be very clear how do we go around LDA. So see, I have certain documents. Uh, so say data set is given to me, all news articles of country France from 2018. Okay, and I want to make Use of LDA to find out these topics. Use of LDA to find out topics. So example is France won 2018 World Cup. Okay. Now, if I want to do LDA here, so say this is the example and the document was containing the words. Document has words. So your unique vocabulary V. Okay. What does it have? The words as football, World Cup, 2018 winners, and France. So your vocabulary size is 5. Okay. So assume your document I, it has these words: football, World Cup, 2018 winners, France. This belongs to topic 3, 2, 1, 3, 1. So this is topic 3, topic 2, topic 1. A document I you have, and in that you have been given different words, and what the words, they belong to which topic, that is also given. Okay, this is given in question. So we have to see how we will do LDA. So what LDA will do, this is the random assignment that LDA does. This is the random assignment of topics to words in a document. So LDA begins by doing this. This is step 1. This is the random assignment of the topics, and the number of the topics, K is the number of topics. How many maximum topics I can have, this we should define beforehand in LDA. So let's say it is given in the question that you can have at max 3 topics. So what LDA will do now? So tell me, in this document I, if I write like this, in the document I, how many words belong to topic 1, topic 2 and topic 3? Can you see and tell? What do you think I should write here in front of doc I and T1 cell? How many words in this belong to topic 1? 2? 2018 in France?
2 words.
And 2? Is that correct? Plus, you also have the count. Plus, you also have a count. How many times a word is associated with a given topic. Okay, so say what unique 5 words you had in your corpus was football, World Cup, France. See here in the question in the beginning it was given football, World Cup 2018, winners, France. This is your unique vocabulary. And how many times this word belongs to topic 1, topic 2, topic 3, that count is also given to you. Say it is given in the question 1035, 1081, 4210, 0 0 20 50 0 1. Okay, we are gonna do one iteration of it with one example. Yeah, that's correct, Alu. Thank you. Okay, so the idea goes like this. After the random initialization, what did we assign randomly in the beginning? The topics to which the words in a document belong. So after random initialization, you want to converge at a point. See, in the beginning you assign randomly, but as we do different iterations, you want your algorithm to actually learn whether the word topic, whether a certain word belongs to a given topic or not, right? It should not be the case that the vegetables belong to the topic of educate. No, not say education. To the topic of entertainment or something random should not be the case. Okay, so you want them to converge at a point where words signify the topic that you are trying to figure out. So what we do, we can go on reassigning. In the beginning, I assigned the topics randomly, but I want to converge to a point where the word should actually belong to a certain topic. It should make sense that the words like recipe belong to cooking, okay, or ingredients belong to the word cooking, to the topic of cooking, right? Sachin Tendulkar belongs to the category or the topic of sports, right? And not to the some random topic of industry. Okay, so what you do now is you go on reassigning. What you will reassign? You will reassign the topic of each word at every pass. This is the most important step. So say now I in my example I am trying to tell you for this word World Cup. Okay, initially I assume that 10 times this word World Cup belonged to the topic 1 time it belonged to topic 2, and 0 time it belonged to topic 3. So in my example, I am trying to reduce this count. See, the topic 2 to which it belongs does not make sense, so I'll try to reduce it. I try to reassign the topic. So what will happen? I will exclude this and make it 0. Okay, so this is just for an example that I am taking. So I reduce the count of World Cup belonging to T2 from 1 to 0 and remove the topic assigned to it. When I remove the topic assigned to it, so I reduce the count from 1 to 0. So now the count will change or not? So then the count changes. Which count will change? If you remember, in the beginning we wrote this table, right? That for the topic 2, the word World Cup occurs 1 time. Now that I have said that World Cup does not belong to topic 2, I want to reassign this thing. So this count will change from 1 to 0, right? So once it is changed from 1 to 0, what will also change is this. Sorry, I reduced here for the word 2018. I think it should not be reduced. We were trying to reduce for World Cup. So let us rectify it. We were trying to reduce for World Cup. So we have reduced it from, now that we are saying that the World Cup does not belong to topic 2, right? So we reduce the count from here. Also we have to reduce from here. So then from 8 it will become 7. So now what you will do, reassign the topic based on probability distribution. That is topic 1, topic 2, topic 3. So this thing is very important. I think you will see it as a part of Gibbs sampling in the lecture series. How much document likes each topic based on other assignments in the doc. So what was in the beginning, we had topic 1, topic 2, topic 3, and in the document I there were 2 words that belong to topic 1. After we reduced the count, it became 0. This also was 2, right? And then in the next step, what you will also say is, say you are having different topics. Topic 1, this is the distribution of words. Topic 2, topic 3, keeping it low because there was no word that was belonging to it, and this is the topic 3. So here you saw how much the document likes each topic based on other assignments in the doc. Also it depends on how much each topic likes the word. What is the probability that you always see that the word Sachin belongs to the category of sports, or World Cup belongs to the category or the topic of sports? How much each topic likes the word World Cup based on other assignments, based on assignments in other documents. So for World Cup, what came out here? Topic 1, topic 2, topic 3. Can you tell me for World Cup what came out after we reduce the count? So what did it come out as? 10, 7 and 1. Is that correct? So how much each topic likes a particular word? So for the topic 1, you have the highest probability of getting the word World Cup. For topic 2, it is less, and for topic 3, it is marginally very, very less, right? So it came out as 10, 7 and 1. So then you multiply both of these values to get your overall answer. And we saw this in the distribution, alpha and beta, probability distribution of the topics in a given document, in the probability distribution of the words over a given topic. Okay. So
How is this 50th parse and 10th parse to compute? The initial
sorry,
state will be given, is it?
sorry, I didn't
In
get your
second,
question.
certain questions. You was talking about this is the 50th pass what we are doing, iteration what we are
No, no,
doing.
I didn't say that it is 50th pass. I just gave you one example that this is one pass. Okay. Like
Okay.
this, I think in the paper they have mentioned like how many passes should be an optimal number. I think it is 200 or 20. I don't remember exactly. But in their
No,
research
but
paper
can
they
we
have told.
compute that with one iteration? Can we compute how many it's going to take?
No, no, it will take a lot of iterations actually. This is just one example that I told you for a particular word. And this will happen over a lot of iterations for all the words. So see here you had in your vocabulary 5 words. I gave you just one iteration for this word World Cup, right? But it can happen for all the words and for a larger number of iterations. Okay?
Okay.
Yeah, this was just to explain the working, like how it actually does it. So our
And how about why are they?
yes,
Sorry,
yes, please continue.
in every question actually we see that they have been mentioning as uh, don't consider the current instance.
Where it is written?
Actually, we saw two numerical articles where they were mentioning don't consider the current instance.
Okay,
Okay,
so
anyways, we do the questions, it may come more.
okay, I do not have any such question. If you do have, please share with me. But what that could possibly mean is like you begin with a random assignment to the topics, right? And over the iterations, you actually learn whether that words that you had assigned initially, whether they belong to a particular topic, make sense or not. And if it does not, then you reduce the count, right? Is that clear?
This topic random assignment we do ourselves, is it?
Yeah, see, this initial thing that we have done is we have done by ourselves. This thing I written in the beginning only. Uh, we have randomly, you had 5 words in your document. See, let me go to back to the question. You had 5 words in your vocabulary, and in the beginning you do not know this word belongs to which topic. So I just but I just know that I have maximum 3 topics in my document, right? So I randomly said, okay, let me assign topic 3 to football, topic 2 to World Cup, topic 1 to 2 2018, topic 3 to winners, and T1 to France. So this is some random assignment I did in the beginning, and this is what I got. So later I think, and also this distribution is given to me. This is given to me. How many times a word is associated with a given topic. So I think that, okay, maybe the World Cup does not belong to topic 2. So I should reassign. Then how does that reassignment happen? Okay, that is what we are trying to figure out. So then I have tried to reduce its count.
So based on this matrix, you decided that we have only maximum 3 topics.
No, no, it will always be given in the question in the beginning how many topics maximum are allowed. This LDA cannot decide by itself.
Okay,
This I have not figured out.
okay.
This is given. Actually, this thing is not given. This thing is given. Only this thing. Okay? LD cannot decide by itself. Okay, it can decide whether this word in a document should belong to topic 1 or topic I. But maximum, will there be N topics or I topics, that LDA does not know. That the user has to specify. Okay, or the programmer has to specify. There are other variants, like if you see in hierarchical LDA, you can figure that thing out also, but in the standard LDA that we are talking about, you do not know. That algorithm cannot figure out by itself what is the number of allowed topics. You need to specify. Okay, is that clear? Is that clear? Okay, I hope it is. So it comes out as how much doc likes or document likes each topic into how much topic likes a given word. So this process you will repeat for all the words in your corpus. Repeat for all words in the corpus in one pass. And depending on what distribution comes out, that way you will decide whether this pass was correct or not. Depending on how many passes you have in LDA setup, this process keeps changing topics for all words, or it keeps on reassigning topics for all words. at every pass. And after that, your desired convergence state will come. A stage will come when whole convergence would happen. Like then, whatever the distribution of the topics for the words is, or the words belong to a given topic, that would actually make sense as how you want it to be. So, okay, I hope this makes you clear the concept of this LDA one pass. So I think we did also question 1 and 2. So can you please tell me what should be the answer for question 3, whether it is supervised or unsupervised topic modeling? So LDA is one such example of topic modeling. So what do you think, it is supervised or unsupervised? Or is it semi-automated? Yeah, unsupervised, that's correct. I hope it makes sense to all. So it is unsupervised. Why it is unsupervised? Because it is not using the labeled data in the beginning. Labeled data means in the beginning it does not know which topic a particular word belongs to, right? You have the word football, but whether it belongs to topic 1, topic 2, nth topic, or which topic, it does not know. And in supervised case, see, I hope you do know the difference between supervised and unsupervised. Say, is it working? Yeah. Okay. Just a second. I don't know. Say you are doing the spam ham classification. है ना? Spam means 1 and ham means 0. You have two classes. And email 1 is given to you. It has the label 1. Email 2 has the label 0. Email 3 has the label 1, and so on. These labels are given to you in the beginning. So tell me, do you think this is if this kind of data is given to you in the beginning, so that kind of a process is supervised, okay? But if the target label, whether it is which class to which it belongs, this particular email sample belongs, this is not given to you. So then in that case, it would be an unsupervised process. Our LDA is also an unsupervised learning algorithm, because here our target, sorry, are you saying something? Are you saying something? Somebody is trying to say something. If I missed that, please let me know. Or shall I continue? Was there any doubt in between? Okay, 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 let me continue in that case. So in here, what we mean by saying labeled data was, we didn't know what the initially in the beginning, when we were beginning this process, we didn't know which words belong to which topics. We just knew the number of topics. So same thing is written. It operates solely based on the assumption that the documents are generated from a fixed number of topics, and this fixed number of topics is given by the user in the beginning. LDA by itself cannot figure out how many topics are there, and our goal is to uncover those topics. So say in your vocabulary you have 5 words. So W1 belongs to, and you had 3 topics. So W1 belong to topic 1, topic 2, or topic 3. So here you can assume that your topics is the labeled or the target data. Okay. And if you do not have the external guidance or the criteria, that is how many number of topics should be there, it we cannot be able to determine the optimal number of the topics and the correct distribution of the topics in a particular document. So I hope the explanation makes sense. Is this clear? Why is it unsupervised? I hope till this point it is clear to all of you. It is not clear? No, ma'am. Is it clear or not? Okay, okay. Okay, great. Then let us continue further. So next question goes like this. Can you tell me which of these are the topic models? And please put your answers in the chat box. Yeah, I think in my screen it became visible all of a sudden. So yeah, the correct answer is D. So all of these, latent semantic indexing, LDA, PLSA, probabilistic latent semantic analysis, all of these are the examples of different topic models. So LSI or LDA, all of these are the topic model techniques. LSI, that is latent semantic indexing, and probabilistic latent semantic allocation, I guess. Yeah, analysis. Sorry, these are the ancestors of LDA, and they help to capture the semantics in some sense. But LDA is the latest technique. I mean, if you consider the history, so LSI and PLSA came first, and then LDA is built on the top of these two. So these are the ancestors, and LDA is built on top of these. So all of these are the examples of topic modeling techniques. Okay. So the correct answer here is D, option D. So can anybody tell me, this we covered in the previous lecture, so one question, but I felt it is good to revise the previous concepts also. What should be the answer for this? Please take your time to solve and put your answers in the chat box. A. How many of you say A? Okay, but yeah, that's correct only. So should I explain? Okay, I'll explain only. I am not sure how many of you were able to solve it. So if you do remember, TF-IDF, it is the multiplication of two terms, term frequency of the term in a given document into the inverse document frequency of a term. So what is this? Number of times T appears in D upon number of terms in D, that is your term frequency. And inverse document frequency, number of documents in corpus upon number of times number of documents that contain the term T. Is this formula correct? So this is the, if you see, this is the raw count only, but this is the most important term. It gives higher weightage to terms that occur with less frequency. So it means it gives importance to the rare terms. Does it remain same for all the terms, like for a given term across the whole corpus? Does this term remain the same for a given term across the whole corpus?
No, it can change, the number of words in a doc. I mean terms.
Actually, it should remain the same. I am talking about a particular term T. Say the term is sports. So, will the inverse document frequency of sports change or remain the same across the whole corpus?
Yeah, the corpus is not constant, right? It can add on
But I am
over the
talking
period.
about a one corpus. See here, I am talking about a corpus. What is a corpus, first of all?
It's a complete dictionary of terms. I mean
No,
words.
no, that is not correct. Corpus is the collection of documents, right? So say I'm talking about Wikipedia articles. So all the articles that are having Wikipedia pages, Wikipedia is my entire corpus, is my entire database. Okay, now there are different Wikipedia pages. One is about APJ Abdul Kalam, one is about ISRO, one is about Obama. So those are different documents. And now Obama can have the document Obama can have the terms like White House, President, Kennedy, right? So all of those are the different words or the terms. So the distribution of the IDF of a particular term across this corpus of Wikipedia articles will remain same, because the number of the documents that are containing the term T in one corpus, it is not changing. The number of the documents in the corpus is not changing. So how can IDF change? This is one important question that I think I covered it on the lecture on Saturday. So maybe you just take a note of it. Okay, I hope it is clear now. So the correct answer here is A. Okay, is it clear? And from this, I remember one of you wanted also to cover this question. Leacock Chodrow distance. Let us discuss that first. So was that clear to you? Who had asked? I do not remember the name. I think Vandana, was that you who had asked? Is it clear or should we still discuss it once?
About what, ma'am?
Leacock Chodro distance, I think you told me on Saturday.
Yes, ma'am. I was cleared about but the evaluation was incorrect.
Yeah, so what
There,
answer do you get? I'm getting 0.69 something.
I was getting something, but I think 0.301 because the path length was 5 here.
So let me
Since
remove.
that question answer key was incorrect, they may review.
Okay, let us see what is the answer in the answer key. According to me, for me, the answer was coming like 0.6 something. Not sure what is the answer that is coming for you. I think the numerator term is not correct. So if you see here, let us see like what are the different opinions, how different students have solved. We want to this house, between house and design, we want to calculate, right? So what is the common ancestor that they have is artifact. So from house till artifact, what is the path length? 1, 2 and 3. From here the path length is 2, right?
Yes, 5.
No, I'm not saying 5. I am saying 2. Either it should be 3 or it should be 2, right? See, from here till artifact, what is it? 1, 2, 3. And from design till artifact, what is it? 2. What is the depth of the tree? 1, 2, 3, 4, 5 till the leaf node. So according to me, it should be like minus log of path length C1, C2. It takes the minimum of C1 and C2. So minimum of C1, C2, 3 comma 2 will be 2 upon 2 into 5. So that is minus log of 0.2. So
But ma'am, path length means reach to the
Source to the destination.
source to the destination.
so what is your source here?
House.
House and design.
And destination is?
Design.
Design.
You are saying source is house and design and destination is design. Is it?
No, house is source and design is destination.
Yeah, C1, C2 is
How
also design, so
how
path length will be 2.
how many ages we have covered from house to design?
Who said like that?
I think path length is this in the discussion.
I mean, the question it is given us similarity between house and design. So we have, I think so, we have to consider the path from house to design.
Okay. For me, I assumed like it is like going till the common ancestor, and then I took it as like minimum of accord. Actually, if you see here, so have all of you done like this from house to design?
Yes, ma'am.
Mm-mm.
As you said, we travel still the common ancestor,
Mm-hmm.
and from that is from house to the common ancestor. That is house to building, building to structure, structure to artifacts, artifacts to decoration, decoration to design. This is
Mm-hmm.
the path length we had considered. So it comes 5. Path length as 5.
Okay, so according to that, then minus log of Path length C1 to C2.
5
5
divided by
upon 2 into 5. So that is minus log of 0.2. Right?
oh yes. Yeah.
And what does the answer come out in that case?
0.301029.
But that is not there in any of the options.
Yeah, so we had choose option as D, none of the above.
And you got 0 marks for that, is it?
Yeah.
Okay, maybe I'll look into it and speak with them to update the solution as well as, reward the marks if it is possible now. Okay? Is that fine?
Yeah, ma'am. Please.
Okay.
Okay. I'll look into it.
Actually, what the method he used was correct, no, ma'am?
Actually, I
Or,
think
or the
maybe I'll need to check it again, but I came up with a different solution actually. I'm not sure whether it was correct or not. That's what I'm trying to still see.
Ma'am, if for the same question that we have discussed in the previous session, house to door, then there was path length of 4, I think so.
Mm-hmm.
So path length means how we traverse the house to door. So
Okay.
there were 4 edges. So we take the path length as 4.
Mm-hmm.
The same process we have followed in this question.
Okay. Maybe what I'll do is I'll again look into it, है ना? Because I think the solution also is not correct. We can take this up again in the next session. We'll have 2 more sessions, right? After this, I think we are having 2 to 3 more sessions. So maybe I'll discuss this point again. Let me contact the support team also. Okay?
Okay, ma'am.
okay.
Yeah. I'll get back to you on this. So, picking up on where we left was this. Can all of you please try the? Just a second. Stop presenting. Just a minute. Give me a minute. Just a second. I'm sharing my screen again. Can you see? Yeah. Can you see my screen? Can all of you see my screen? If you can, then please
Yes,
attempt.
ma'am.
Yeah, please go ahead and attempt this. Okay, I think I already have answers coming in. Okay, great. A. Is A the answer for this? Just please try to solve this, and we will discuss what is distributional hypothesis, what is statistical measure hypothesis, and whether LSA and LD are based on one of these two or both of these or none of these. Just try this one. What is the answer? Is any one of you aware about the distributional hypothesis and statistical mixture? So here, I think should discuss it now. So here the correct answer is both of these. Okay. Why? Let us see why. What is distributional hypothesis and what is statistical measure mixture. So distributional hypothesis, as I discussed in the beginning, what are the what are the two distributions that LDA makes use of? Dirichlet. What is it? Distribution of distributions. What are the two distributions it takes?
Topic to words and
And
word to topic and topic to
yes.
document.
So it takes the distribution as word to topic and topic to the document, right? So definitely it is a distributional hypothesis. That's what I have also written here. See, distribution hypothesis, it applies to both LD and LSA, and also in one sense it means that words with the similar meanings, they belong to the same topic. So say World Cup. World Cup has a tendency of belonging to the topic of sports, right? Pitch, cricket. So similar words, similar kind of words, World Cup, trophy. These are similar kind of words. So they have the tendency of belonging to the similar topic, that is sports. So similar words with similar meanings, they tend to appear in similar contexts within the documents. Okay. And this is our statistical mixture hypothesis that I just discussed here. That is, a topic is a it takes the per topic distribution and per word distribution. Okay, that is the statistical mixture hypothesis. Okay, so distributional hypothesis means a topic will have the words with similar meanings. Okay, how frequently the two words World Cup, winners, World Cup or cricket, they are occurring together. As to how many times they occur together, they have more tendency of belonging to a certain topic. And statistical measure is statistical whenever the word is probability thing comes. Document is a mixture of latent topics, and each topic is characterized by the probability distribution of the words. So LSA will use only the distributional hypothesis, but LDA will use statistical combination as well. Okay, is that clear? Does that make sense? So now can we answer this? Question 7. I think now you should be able to answer this. In the case of distributional hypothesis, what did we assume? And which of these options satisfy that property? That it said now words with similar meanings occur in similar context. So which option do you think best suits that? Waiting for your answers. A. That's correct. Words with similar meanings appear in similar contexts that we had discussed here in the distributional hypothesis. So, if they are appearing within similar contexts in the documents, means they are belonging to the similar kind of topics. So, similar topics make use of similar words. That is the answer. So, as a statistical mixture hypothesis, what do you think? As a statistical mixture hypothesis, which of these options satisfy for LDA and LSA? LSA is nothing but latent semantic analysis, one of the topic models. And we know that they both satisfy the distributional hypothesis as well as the statistical hypothesis.
Ma'am, please go back to the previous question.
Mm-hmm. This one?
Yeah, thank you.
Okay. I'll be sharing the slides and the notes video lecture also. So that should not be a concern. But if you do have some conceptual doubt, then please ask. I hope it is clear what is distributional hypothesis.
Distribution of words in a topic and distribution of topic in a document.
That
This
is
is the
that is statistical hypothesis. Distributional hypothesis is this: similar topics make use of similar words. See, words with similar meanings, they appear in similar contexts within the documents. So if the two words like World Cup and cricket, say COVID and Wuhan, they occur together, so we are likely to assume that these belongs to the coronavirus topic, right? So how many times these words are co-occurring together? That is the distributional hypothesis. Vaccines. Okay. So that is kind of distributional hypothesis, and statistical mixture hypothesis is what you just stated. Distribution of the word belonging to a certain topic and the distribution of the topics for a given document. This is the statistical hypothesis. Is it clear? Is it clear or not?
yeah. Yes, ma'am, clear.
Okay. So shall we move ahead to question 8 that we were actually discussing? What do you think? What do these talk about?
I think option A document talk about several topics because it is taking statistical mixture hypothesis.
Yes, that's correct. The correct answer is option A and not option C. I saw this answer in the chat. See, prefix topics means that you have defined the topics beforehand, right? Whether it's the topic of sports category, what all those topics are, you have specified them beforehand. But that is not the case. You just specify in the beginning, you just specify K. What is K? K is not the topics but just the number of topics. Your document can belong to a maximum of n topics or k topics or I topics, right? But what those k topics themselves are, that you do not define beforehand. It initially in the beginning it assumes randomly, right? Then it keeps on reassigning till it converges to the desired distribution. So we can say that the document talks about several topics and not prefix topics. And this point is distributional hypothesis. Is it clear? Is it clear or not?
Yes, ma'am.
But there is no way that a document has everything belong to a single topic.
That is one of the edge cases, right? It can the entire document can belong to a particular topic, but that thing you do not know beforehand. What you do know is maximum I can have 20 topics or maximum I can have 3 topics. But what word, every word in your document, whether it belongs to first topic, third topic, second topic, that you don't know. Or what those topics was, what those 3 topics actually are, whether they are sports, politics, education, whether they are sports, entertainment, army, defense, that you don't know. Okay, a
Yeah,
document can entirely, all the words can definitely belong to a particular topic, but you do not know in the beginning whether it does or it does not.
sure, ma'am. Thank you.
Okay, that's, yeah. Any other doubts to anybody else, or shall we proceed? Okay, great. So let us move to the next question. What do you think about this? True or false? I want the reason also. Because in the exam the same can come in the form of choose the correct reasoning. So you should be clear with whether it is true or false and why is it so. Okay, great. Thanks for letting me know. What is the difference between syntax and semantic?
Syntax is grammar and semantics refers to the meaning.
Syntax is always the grammar. It is like a set of rules. Maybe it is grammar is just one aspect of it. Dependency parse tree, right? Parts of the speech. So all of those come under the syntactic category. Yeah, and semantics is meanings, that is fine. So can you tell me like whether it is true or not? Also, you're missing like one important thing here. Maybe once we discuss, I can tell that point. What do you think? Yeah, that's the correct answer. For this, neither the word order is not important. Whether the word football follows France or France follows football, it does not care what the order of the words is. What it does care is how many times a word is occurring, a word is belonging to a certain topic, right? Or how many times a document belongs to a certain topic. So it only takes the frequency information into account, that probability distribution. It ignores the syntactic information. Word order is not at all important. And it is similar to the bag of the words approach. There also we treat like how many times a particular word occurs in a given document, and then we keep on updating the count of it. So that is correct. So I have also written the reasoning. So first of all, the answer is true. And why? We have written they focus on only the word co-occurrence, and they treat the document as the bag of the words. They ignore the syntactic structure, word order. And why is it so? Because this way they can be able to handle a large number of documents, right? But they cannot capture what is conveyed through the sentence structure. Grammar. Sentence structure means what are the parts of the speech. Dependency parts tree. Okay, grammar you know already. So that this point is also clear, word co-occurrence. And so what do you think this word co-occurrence is, whether this is statistical hypothesis or the distributional hypothesis? Which it comes under which point? Word co-occurrence, I discussed it. Can you please tell?
Similar words belongs to similar topic.
Yes, so it is distributional. Okay, I am focusing on this point again and again. It is very important. Please keep in mind the distributional hypothesis is similar words, they belong to the similar topics. Okay. So that helps you to figure out the word co-occurrence. Similar words, lovely and beautiful, they occur in which context? So they have the category of describing the aesthetics or something, right? Or sunrise and sunset, they always occur together. So they have the top probability of belonging to the topic of nature, right? Or photography. We do not know, but then this word co-occurrence helps us to figure that out. So this kind of a thing is distributional hypothesis. But statistical hypothesis is how many times a word belongs to a given topic into how many times, what is the probability distribution of topic of the document belonging to a particular topic. Okay, so this is your statistical hypothesis. This is very important. Please keep in mind the questions can be twisted and asked from these 2 points. Again and again I am focusing on this point. If it is not clear, please let me know, I can explain again. Is this point clear to all? So if you see from question 6 till 9, they almost follow each other, right? So all of are kind of based on statistical and this distributional hypothesis. So please let me know if you understood both the hypothesis clearly, or should I explain once more? All of you understood or not? Okay, great. Can you please explain statistical? Sure, sure. So the statistical hypothesis goes like this. So this is important for LDA. It suggests that the document is a mixture of topics, right? This thing, document is a mixture of topics, and each topic is the probability distribution of the words. So this thing, the basic formula of LDA, the basic equation, that is the statistical hypothesis, the one that we discussed in the beginning in huge detail. And I also give you one iteration example. So this thing, this is the statistical hypothesis. Is it clear? I hope now you can relate. What is the probability distribution of the words over a given topic? What is the topic distribution for a given document? This is your statistical hypothesis. Okay, great. Super. Let us move ahead. Question 10. I guess we are on question 10. Yeah. I think this kind of a question you have in your current assignment also, 1 and 2, but in a different form. Assignment 9, I think it's question 5, or I think beginning question. I don't remember the question number. But yeah. So here what I'll give you a hint. You should know what alpha and beta stands for, and that would help you for the first and the second statement. This we discussed in huge detail. Tell me whether the third statement is correct or not.
Correct.
Correct. This we discussed in huge detail in the beginning. So the topics, who will specify? Number of topics? Who will specify?
Alpha.
No, user will specify.
Okay.
Like in case of
Hi.
data structures, you define the size of the array first when you are declaring it, right? It is not a dynamic data structure, it is static, right? So here also you can assume this is, here you need to define the number of the topics first of all. That will be specified by the user. Now decide based on alpha and beta what should be for 1 and 2. This is very important conceptual question. I will show you in what form, twisted form it has been given in your assignment. So let me tell you, open the assignment and tell.
This answer is 1 and 2, right?
Answer is 1 and 2. So statement 2 is not, 3 is not correct. 3 is not correct. Please rethink your answer. So
It is all of us.
sorry.
All of the above.
Yeah, that's correct. So see, in your assignment you have been given this kind of a question. Question 3. Same concept applies, but the same question, same concept in two different forms it has been asked. Okay, I'll give 2 to 3 more minutes because this is very important. So think and write. One of you is able to figure out correctly. Answer is option D. Shall I proceed with the discussion? Because all of you got to know the answer before. Okay, I think, yeah. So if you see what is the probability of distribution of the word belonging to a certain document, it goes like probability of the word belonging to a given topic into, no, let me write it like this. That is how we decided alpha and beta in our case. So it is tell me what is this? What is this term?
Alpha.
First one is alpha, second one is beta.
And what is this, topic distribution or the word distribution?
Alpha is topic distribution.
Yes, for topic distribution over a document. This is word distribution over a topic. Now, what does the question say? A low value of alpha will assign fewer topics to each document. If I have low alpha, it will assign lesser topics to each document. That is correct. And if I increase alpha, then more topics will be assigned. That is correct, because T appears in the numerator of it, right? And for beta, what does it say? Low value of beta will use fewer words to model a topic, right? And a high value will use more words. That is also correct, right? But say this is correct, third was also correct. So the answer is this, D. But say in the question I just say choose the incorrect statement, and here I write beta and here I write alpha. Then, and I say choose the incorrect statement. Then what should be your answer? Follow the green stroke. What should be your answer in that case?
Only C, no?
I'm asking choose the incorrect statement.
A or B.
A and B. Okay, 1 and 2. Correct? So you see the concept remains the same, but it can be framed in 3 different ways. 2 ways I have told, and in the question if you see, now can you help me answer this question? Assume alpha is per topic distribution, beta is per word distribution. So now he is asking that I want lesser words for our given topic. Sparse means less, denser means more, and he wants a denser distribution over the topics. So what I should do?
Alpha should be increased.
And what about beta?
Should be decreased.
Okay, great. So what is the correct answer?
Fourth.
So okay, clear to all. Same question, 3 different ways to ask. There can be multiple different ways. 3 I have, 2 I have covered, 1 they have given. Correct or not? Okay. Now, one question that I thought, yeah. So maybe you can go through this explanation later. So yeah, this question is there in your assignment. Last question. How many of you were able to solve it? First of all, let me tell me this thing. How many of you are able to solve it? Raise your hands. Great. I'll be covering this. So just have a look at the question first. So, so what answer you are getting, Lokesh, for this? What answer you got? Option A. That's, I think I also got option A. Yeah, that is, I think then we can discuss. Yeah, okay, great. So let us solve it. I thought most of you might be stuck and it seems a little important. So yeah, let us discuss. So in the question, if you see, yeah. So he has asked you a question about Gibbs sampling. First, try to figure out the key terms, what the question is saying. Alpha. So this is alpha and beta. So the corpus has 3 documents. Keep on noting down the important points as you see. 3 documents, 5 words. 5 words means vocabulary size is 5. Okay. What are those 5 words? Machine learning, language, nature, vision. Machine learning, language, nature, and vision. These are the 5 words. This is 1 point, this is 2 point. How many topics? 2 topics. Topics we represent by K or capital K. documents by D, vocabulary by V, capital V. Okay. It appears more of like an M. Just a second. Okay. So at a certain point, he says the structure of the documents is like this. Doc 1 is having this distribution of the topics. Doc 2 is this. This is nature and not mature. While copying it, got like this. It is nature only. And doc 1, doc 2 and doc 3 is given. Okay. Number inside the bracket denotes the topic number 1 and 2. And eta is 0.3 and alpha is 0.3. Eta is 0.3, alpha is also equals to 0.3. So these are the important terms that we got from the question. So now he is asking, calculate for question 8 the value for value up to 4 decimal points. What we are going to calculate? What is the estimated value of beta 2 nature at this point? So he is asking that nature should belong to topic 2. So he is asking you the value of beta 2 for the word nature. Okay. Initially, if you see, yes, I also got the same. That's correct, I guess. Then, so if you see, nature in all the documents, in document 1, nature belongs to the first topic. 2 times nature is 3 times nature is occurring in document 1. It belongs to the first topic. And nature is occurring 2 times in the document 2, again belonging to topic 1. And nature is not at all occurring in the document 3. But the question asks you, what is the probability distribution that nature should belong to the topic 2, right? So I'll do a step-by-step solution. So if we want to calculate beta 2, the word nature at this point in Gibbs sampling, we need to see how many times the word nature is assigned to topic 2. What does beta 2 means for nature? That is what I'm trying to explain. And then you add the smoothing term. What is the smoothing term here? What is the smoothing term? That is eta, and its value is given to be 0.3. Okay. So if you see in document 1, in document 1, is there any topic that belongs to the topic 2? Is there any word that belongs to topic 2 in document 1? Does nature belong to topic 2 in document 1? And if yes, then how many times?
No, it's not available.
Yeah, it's not there. So what you will write in doc 1, we are writing for the word nature. Please focus on this. Doc 1, nature appears 0 times. It belongs to topic 2. In doc 2 also, it belongs 0 times to topic 2. And in doc 3 also, 0 times it belongs to topic 2. Is that fine? So if now we want to calculate beta 2, what does that come out? Count of nature assigned to topic 2 plus eta, because I said add the smoothing parameter, upon count of, because again it is a probability distribution only, count of all words. All words means my vocabulary. All the words that have been assigned to topic 2. But that does not mean unique here. So count, we are taking the count of all the words that have been assigned to topic 2 plus eta. Now tell me, now tell me, count of nature assigned to topic 2 is what? Across doc 1, doc 2 and doc 3?
0.
That is 0. And can you tell me count of all words assigned to topic 2? See this and tell, count very carefully and tell me from here. Count of all the words that have been assigned to topic 2 across all the documents, all the 3 documents. What is that? Can
11.
Yes, that is correct. 11 is correct. Let us see why it is correct. So if you see here, this is doc 1, doc 2 and doc 3. Doc 3. So in doc 1, all the words are belonging to topic 1. So no word is assigned to topic 2. In doc 2, let us see. This is one word that belongs to topic 1, doc 2, 1. Plus this machine, then learning, so 3. In doc 3, tell me. In doc 3, if you see, all the words that are there, they belong to topic 2. Right? So how many words are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8. And now, what is the count of all the words that are assigned to topic 2? That is 8 plus 3, 11. So this value comes out as 0.
In topic 2, we cannot take the unique words, is it?
Yeah, that is what. That is the most important point that I was waiting somebody will ask this question. So here you will not see like this, that in the doc 3, language is assigned to topic 2 two times, but you are considering only the unique word. So you reduce this count to 1. That will not happen. We are talking about count of all the words across all the documents. Vocabulary is the set of the unique words that is there, but that does not have any role to play here as of now. What you have
But
to
in
focus is, sorry,
topic also, it will be listed once, but linked to multiple docs, right?
yes, that's why we always say it is the word distribution of the topics. How many times, what is the tendency of the word belonging to a particular topic, right? That's why we say talk about the probability distribution. So say probability of World Cup belonging to sports is 0.5, whereas probability of cricket belonging to sports is 0.6. So it is a probability distribution of different words. But then there can be different words that belong to the same topic. For education, the different for the topic education, the different words can be there: BTech, MTech, MBA, UPSC, IAS, right? Entrance, jobs, new education policy. So all these are different terms, but they inherently belong to the same topic. But then it is not also the case that UPSC only belongs to the word topic, only to the topic of education. It can all, if there is a separate topic as entrance exam, so UPSC can also belong to that. And if there is another category like toughest exams in India or exams is yet another category, or yet another topic, so UPSC can also belong to that. That's why we always take the probability distribution of a word over a given topic. Okay, is it
Yeah,
clear?
ma'am. Thank you. Yeah.
Yeah, okay, great. That is what the most important point that I wanted you to know, that you would not reduce this language count to say that machine is appearing 1, 2, 3, 3 times. So you just take its count as 1 in doc 3. That will not happen. You just count all the occurrences of it. All means all only. Count all the occurrences of it. So we're not talking about vocab, we are talking about count all occurrences. So duplicacy is allowed. Duplicacy is allowed. Okay. So what does it come out as? Eta value was 0.3. So 0 plus 0.3 plus count of all the words that are assigned to topic 2. What was that?
11.
11. Eta was 0.3 over.
3 only.
Sorry. Yeah, a little change in the formula. So this is eta times vocabulary size. So here your unique words come into account. So this will be 11 plus 5 into 0.3. Okay. How many unique words are there? You will count all the occurrences of those words. But then what are the unique words? How many unique words we had here? Machine learning, language, nature, vision. 5 words. Okay. So that we kept here. So it came out as 0.3 over 12.5, which comes out as 0.0240. Correct? Is this clear to all? And into vocabulary size. This was a little change in the formula. Okay? Is it clear to all? Is it clear to all or not? Okay then. Thank you. Thank you for joining. And
Ma'am,
Ma'am, would you repeat the LDA allocation that you have explained in the starting of the presentation?
okay, which particular point do you want me to explain?
The numerical that you have discussed.
Yeah, that was just one iteration. Let me summarize it briefly. Will that do, summarizing briefly?
Yeah, okay.
Okay. So say in the beginning, I hope this statistical distribution is clear to you. Word to topic distribution, topic to document distribution, and it is the multiplication of these two terms, and T is the total number of topics that you have, and you can visualize it in terms of these two matrices. So the example that I had taken was, say you had a vocabulary which consisted of 5 words: Football World Cup 2018 winners and France. Okay. So how does LDA begin? the number of the topics will be specified in the beginning. In my case, I think I took as 3 topics, right? Yeah, I took as 3 topics. So what does it start with? It will randomly, in the beginning, it does not know which word should belong to which topic in a particular document, right? So what it will do, it will randomly assign the topics to the words in this ith document. Okay, we are talking about one document here, and so this document was having different words in it, and now the to which topics these words should belong, I don't know. I assign it randomly, right? So then what will happen is, at a point I want what the idea is, and this table will be given to you. Topic to word distribution. This particular table will be given to you, topic to word distribution, that you have not done. Okay, the idea is, after initializing randomly, you want to converge at a point where the words that appear in a particular topic, they should actually belong to that topic, right? They should make some logical sense. That is, the World Cup or the trophy, cricket, football belonging to the topic of sports, that should make sense. It should not be the case that vegetables is belongs to the topic of sports. Okay, so you want to converge at a point where the words, they signify the topic that you are actually trying to figure out. And if that is not the case, what you will do, you will reassign the topic of each word at every pass. And how many passes you do, that in their paper, research paper, they have predefined as a specific term. But I'm explaining for one pass for one particular word, that is World Cup. So say, in the beginning I said that World Cup should belong to topic 2, and the probability, and how many times this happens is 8 times. But then I want to reassign the topic of the word World Cup. What I will do, in the beginning, this topic to word distribution came out like how many words they belong to topic 2. Only one was belonging in the beginning after my initial assignment. To topic 1, 2018 France, so 2 here. T3, football and winners, so 2 here. Now I say that the World Cup should not belong to topic 2, or I want to reassign the topic of the word World Cup. So what I do, I reduce this count from 1 to 0. Okay, so if I'm reducing this count, then in this table, this should also change from 8 to 7, because the World Cup belonging to topic 2, I'm saying it does not. So this count I also reduced. And then what you will do, so it is, you can imagine it like this particular term that came out, how much the document likes each topic, and this term that came out, how much each topic likes a particular word. How much the topic T2 likes the word World Cup? 7 times it likes. How many times it likes the word T1 likes the word World Cup? 10 times. Then later, how you will try to figure out the correct distribution? You will take the multiplication of these two terms. T2 into 10 plus 0 into 7 plus 2 into 1. This is for one pass for one word and for one document that I have shown. But you will do it for all the words over all the topics for multiple passes. Okay, this was just one example that I wanted to explain you the working of LD.
Ma'am, if when we are reassigning, so the number of frequencies getting reduced in topic 2. So actually, if then either the World Cup will be reassigned to either topic 1 or topic 3.
Yes,
no?
yes, that
we
you
have
will
to
figure out. That you will figure out based on this probability distribution, whatever the value comes out. Okay.
How I didn't get you. How?
Yeah, I think I have not covered that point yet. I just wanted you to explain a little working of it. Okay, that will happen over the multiple passes in your document, and this whatever the value comes out after multiplication for the probability, that will help you to figure out whether it should go to topic 1 or topic 3. It can so happen that in the second pass it appears that it should belong to topic 3, but then in the third pass the probability for topic 1 comes out higher. Okay, so we do multiple passes till we reach a point where it actually makes sense and it gets stabilized. It does not
Okay.
change so frequently. Okay.
Okay, so the next passes will continue
Yes.
with the previous result. That
Yes.
is from 10,
Yes.
7, and 1, we have to continue
Yes.
the next pass.
So you are taking the results of the previous passes into account through this, and this is anyway getting captured in this point, right? So, and whatever the resultant probability comes out, that helps you to figure out whether the World Cup should belong to topic 1 or topic 3, right?
Okay, okay.
Okay.
Okay. Okay. Thank you.
So, ma'am, you have taken the value randomly.
Yes, in the
Like,
beginning, just to explain to you.
no. After that, you have filled the table, no?
Which table? This
Before this.
this table?
Yes, yes, ma'am.
No, this was given to me. I have
Okay,
written
okay.
plus you have a count of how many times. What I did on my own was this.
Okay. So, at last, you have done this randomly. The table that you have taken randomly multiply with the value given in the question.
Yes. Yes.
Okay.
This was given in the question. I was given how many topics are there. I was given 3 topics are there, and I had how many words are there. So this assignment. So this assignment, whether football should belong to T3 or World Cup should belong to T2, 2018 to T1, this particular random initialization I did on my own and nothing else. Okay.
Okay, ma'am.
Because of this happened. Okay, this was the only step that I did on my own. K was given to me, and this table was also given to me. Okay, is that okay?
Yes, ma'am.
I hope it is clear now.
Yes, ma'am.
Okay.
But ma'am, why we do have multiply these two?
Array, that is the basic concept of LDA, because it assumes that the document is has multiple topics, so we take the per topic distribution over a document. And since the topic can have multiple words, right? A topic can have multiple words, similar or dissimilar, right? So it is the word distribution over the topic. So that's why you take the multiplication of the two to get what is the probability distribution of a word belonging to a particular document. Always visualize, if you are having any doubt, always visualize this in terms of these 3 matrices. Okay. Okay, is that okay?
Yes, ma'am.
Clear or not?
Clear, ma'am.
Okay. Okay, then any other doubts anybody's having? Shall we stop here then, in that case, if there are no further doubts? Thank you. Thank you all for joining. Please practice sincerely. Good questions are there in the assignment. We are also trying to cover some from our end. So please practice, and I hope this should help. Thank you. Thank you for joining today.